Okay, let's start, guys. So yesterday we have started on the hypothesis testing, agree? And then we have seen some example. Okay, so yeah, we have seen what is null hypothesis, we have seen what is alternate hypothesis and how to formulate that. Okay, and we have also seen an example, example of a training program. Okay, and where we have finally decided that we can reject the null hypothesis. Okay, because our value is falling in the rejection region, so we can reject the null hypothesis. Okay, so any doubts from the yesterday's session, guys? Okay, fine. So, and also what we have seen, we have seen critical region. Yeah, so what was the critical region, guys? Critical region is that region in which we can reject the null hypothesis. Okay, fine. So today let's see one more example. Let's say a food snack company, okay, a food snack company claims that their Lays wafers packets contain an average weight of 50 grams per packet. Okay, what they are saying, the wafer contains 50 grams per packet. To verify this claim, a consumer watchdog organization decides to test a random sample of Lays wafer packets. The organization wants to determine whether the actual average weight differs from the significantly claimed 50 grams. The organization collects a random sample of 40 Lays wafers packets and measures their weights. They find that the sample has an average weight of 49 grams with a known population deviation of 4 grams. Okay, so see what's happening over here is the Lays company. Okay, Lays company is saying my Lays wafer packets on an average weighs 50 grams. Okay, on an average weighs 50 grams. That is what their statement is. Now, a government agency or a organization, okay, consumer watchdog organization, they want to test it whether the statement is true or no, wrong, or whether they are trying to fool people. So what they have done, they have considered a sample of how many? 40 samples. Okay, they considered a sample of 40 and then they have done some testing. And based upon that, we need to decide whether this statement, whatever they're saying that 50 grams per packet is true. Can we accept this or not? Okay, that's the point. So here, first of all, what was the mean? The mean is 50 because average they are saying it, the population average they are saying is 50. Okay, and what is the population standard deviation? 4 grams. Okay, here 4. Population standard deviation equal to 4. Okay, and coming to sample, how many samples they are taking? Sample of 40 layers. Okay, n equal to 40. And what is a sample mean? So they found out that the sample has an average weight of 49. So x bar equal to 49. Okay. So these are the values which can be extracted from the given problem. Now, if you go to the steps, if you go to the step, the first part is that define null and alternate hypothesis. Okay. So the null hypothesis will say, okay. So what is null hypothesis will say? Mean is 50. Whenever you are having something equating, so that will be the null hypothesis. Okay, it is saying, hey, the average is 50. Now alternate will say mean is not equal to 50. Okay, see here the point is the consumer wants to decide whether the actual weight differs from the significantly 50. Okay, this try to focus on this line. They are saying they want to check whether the average weight actually differs from 50. That means whether they want to check whether it is 50 or not. That means it could be greater than 50 or it could be less than 50. Okay, but in the yesterday's problem, here our point is the company wants to know if the training program has significantly increased. They were only telling us, I want to know whether the program has increased the productivity. That means greater than 50. I want to test for this. Okay, because they're saying increase, I want to just check whether the latest mu is after the training, whether this mu is greater than 50 or not. I want to test that. I don't want to test for the less than, because I am only concerned about the productivity increased or not. Okay, so that's why I have considered only mu greater than 50 test, and this will be what will be this called as one-tailed test. Okay, one-tailed test. That means only one tail we are considering. Okay, so just to give you a idea about these tails. Okay, see guys, if at all based upon the alternate hypothesis, the three cases of critical region arise. That means what? See, our alternate hypothesis, okay, based up if mu equal to mu naught, this will always be a null hypothesis, guys. Null hypothesis will always say this is equal, mean is equal to some value. But what does this is null hypothesis? But what does alternate hypothesis saying? That could be, it can say no, after the event. What is the event? It could be the training program, or it could be some testing, or it could be some seasonal change, anything. Okay, before and after event. Okay, so here it can say mean is not equal to mu naught, or mean is greater than mu naught, or mean is less than mu naught. It could be any of these three. Fine. Based upon our situation, we need to consider this assumption. In the training program, we have where he's saying that it is increase the productivity. So I am concerned only about this one. Mean is greater than mu naught. Okay, so I will consider only mu greater than mu naught, because I want to just test for the increased productivity. Agree? But if you at all just want to prove that before and after the mu is not equal, just not equal, whether it is greater or less than, I don't want to know, but I want to just prove it is not equal. That means it could be less than mu, and also it could be greater than mu, right? It could be both scenarios you need to consider. So in that case, it will be this. So if yesterday when you considered only greater than 0, okay, only mean is greater than mu naught after the testing, so your critical region will be this side, to the right side. Okay, why? Because you are checking greater than mu naught. Okay, you're checking what? You're checking mu is greater than mu naught. Okay, so that means if your mean is in over here in the middle, okay, so you are checking mu greater than 50, so it will be this side. So critical region will be this side. If it is less than mu naught, so this will be this side, left side. If it is not equal to mu naught, then you need to consider both the sides. Okay, then you need to consider, see, if it is not equal to mu naught, so it could be less than, or also it could be greater than, I don't know. So that's why I'll consider this side is greater than, this side is less than. Two sides I need to consider. Okay, in that scenario, it is called, this is a double-tailed test. So this is one tail, this is second tail. So it's called double-tailed test. Okay, so now if your scenario is just to check mu is less than mu naught. Okay, this scenario, that means, for example, in the training program itself, if he's asking, instead of increasing, if you just ask, hey, if the training program has decreased the productivity, so I'll test only decrease. I'll just check if the after the training, if the mu is less than the original mu. Okay, so I do this, only do test this side. So if mu is here, so I'll just check if mu is new mu is less than the mu naught. Okay, this is a actual population mean. After the training, whether it has increased, sorry, it has decreased. So I'll just check this. So then the critical region will be to the left side. Okay, and if it is the to the right side, then it is obviously called as right tail test. Okay, here we'll check the greater than. So this will be the critical region. Are these three scenarios clear to everyone?
Yes, sir.
Okay, fine. So now coming to here. So can you tell me in this situation which type of test we need to do? Hmm? Our alternate is saying mu not equal to 15. So in this scenario, which type of test I need to do?
One tail test.
One tail. Okay, which side tail? Right side or left side? Yeah, Meghana, you said clear, right? So can you tell me like which type of test we can perform for this? Guys, that's why I'm saying, guys, when you are not getting the concept, so you can tell me why you are stopping from that. I don't know. Because I've just told you, if at all, what is this? This mu is your population value. Okay. What is this? This is null hypothesis. What is this H1? H1 is your alternate hypothesis. Okay. H1 or H8, these both are alternate hypothesis. If you want to do testing for a not equal scenario, first of all, see here, if here what you are doing, you are just saying you want to check if the new mu, okay, new mean, whatever you are getting, if that is less than the actual population mean. Okay, that means what? You're just checking if the value is less than, that's all. You're not checking equal to, you're not checking greater than. No, you're just checking less than. Only less left side of the portion you are concerned. Then it becomes only one tailed test. This is only one tail, you are concentrating only on the one tail. And it is also called left tailed. Getting? If it is greater than mu naught, if it is greater than mu naught, you want to check whether the new mu is greater than the original population may not. That means only right side you want to test. If greater than, if usually the mean, if it is this, you want to check if the latest one is greater than this. That means you are concerned only about this tail. This will be your critical region. And this is also called one tail. This is also only one tail. Only one tail you are focusing. I'm not concerned about this tail. Only this tail. This is also one tail. But what tail? Right tail. Okay. But if it is just asking you to check not equal to mu naught, the new after the testing, whatever you're getting that is not equal to mu naught. If it is not equal to means what? It could be greater than or it could be less than. So both the scenarios you need to consider. This is greater than, this is your mu naught. This is greater than, and this will be less than. So one tail, second tail, two tail test, or this is also called as double tailed test. Is this clear? Yeah, that's fine, Meghana. You can say I'll not ask question. So now in this scenario, can you guess which type of test we need to go for?
Two-tailed test, sir.
Okay, but why you are taking so much time, guys? I am not understanding actually whether you are getting the concept, whether I am able to explain it properly, or is there any gap I'm not able to understand? Because clearly I was explaining this part, but again, if you are having some difficulty, you can ask, but this one, if you are not able to answer, I am not sure. Okay, fine. So now, yeah, I understand that this is a new concept. It will take some time, but I'm just explaining the concept, right? What type of, in which scenario, which type of test we need to do, right? In which scenario, which type of the test. So clearly you can see here, you're just checking for not equal to scenario. That means you're not checking for greater than or less than. You're just checking for not equal to. In not equal to, what type of test we are going for? Double tail test, right? Okay, fine. So now, if this is a scenario, what was the second step we need to go for? We need to go for decide the level of significance. Okay, so usually we go for the alpha equal to 5%. Okay, and after that, if number of samples is 40, what type of distribution I can consider this as? Can someone see me? If number of samples equal to 40, I can assume this distribution is what type of distribution?
Z-score only, sir.
Mhm. No, I'm asking distribution.
Normal.
Yes, correct, Megan. So this can be assumed as a normal distribution, because if the samples is less than 30, you can assume, because now it is 40, you can assume this is normal distribution. So if you are using normal distribution, you can go for the Z-score. Yeah. So now third point is choose the type of test you want to perform as per the sample data, calculate the test statistic, obtain the critical reason, etc. Okay. So now alpha equal to 5, and we have considered it as a normal distribution. Okay. And what will be the next thing? Fourth part is a Z-score. Now coming to the Z-score, you have x bar minus mu by rho by square root of n. Okay. Now what is the sample x bar? X bar is 49 minus mu. What is mu? 50. Okay. By rho is 4 by square root of 40. Okay. What is this? Minus 1 by 4 by square root of 40. How much it will be? Minus 1 divided by root of 40. Okay, how much it is? Minus 1.58. Okay, so this will be minus minus 1.58. Okay, guys, our Z test statistic is minus 1.58. Okay, so now once we got the test statistic, next we need to go to the distribution. We need to go to the distribution and check, create the critical region or the rejection region. Okay, so now let me go over here. Okay, so now if our distribution is somewhat like this, okay, now we need to consider two-tailed test, right? We need to consider two-tailed test. Fine. So one side, sorry, this will be one side, so other side. Okay, now this side will be alpha by 2, this side will be alpha by 2. Okay, what is alpha? Alpha is 5%, guys. 5% is more, is how much? 0.05.
So both sides 0.25, right, Santosh? 0.0.
Correct. So this will be Z at alpha by 2. This will be minus Z at alpha by 2. So this will be 0.025. Okay, alpha is 0.05, alpha by 2 will be 0.025. And this will also be area is this are also 0.025. Okay, and when you will get this value at 0.025, so I think we have already done this in some previous examples, so I will just try to show you. See, alpha by 2, alpha by 2, alpha by 2. Yeah, see, in the previous example, when you are considering two side the test, okay, so alpha by 2, the value will be 1.96. Okay, so the Z score is 1.96. If you see here, okay, can you see 1.96? So I'm not calculating it again, but the way how you can calculate is simple. So here it will be 25, this side will be 25, that means 0.025, 0.025. What will be the remaining left? 950. Okay, so if you want to calculate this particular point, so it will be 950 plus 0.25. Okay, so it will be 0.975. Okay, so if you go to the table and see which particular value is giving 0.975 area, okay, so I'll just show you 0.975. Yeah, so 0.975 over here. Okay, which one? This is 1.9 plus 0.6. Okay, so it will be 1.96. Okay, so the same thing over here. Here also we want two-tail test. So here also our value is what was it? How much is that? 1.96. Okay, so here also our value will be, this will be 1.96. This will be minus 1.96. Okay, fine. So this is what? This is just our distribution critical region. So this is one critical region and this is one critical region. Okay, fine. Are we good till this point, guys? Please tell me.
Yes.
Okay, no doubts, right? Fine. So there are, see, you can understand there are only few major steps. One is just formulating the null and alternate, that is as per the requirement. From this requirement only you will understand which type of test you need to consider. If it is only less than or greater than, only one tail, but if it is not equal to, it is double tailed. After that you will consider the alpha, usually 5%. Then based on the number of samples, you can this will be normal distribution. If it is less than 30, it will be T distribution, then you need to use the T statistic. Okay, that we will see. If it is normal distribution, then you will have Z score. Okay, initially you calculate the Z score. That means our test statistic is this. Now, coming to the next point, from our distribution, okay, if it is normal distribution, what is the rejection region? Okay, for this alpha, this will be the rejection region. Okay, so now what is our test statistic? Z. Okay, and this is minus 1.58. Okay, now can you just look at this 1.58 and tell me whether this value will be falling in the rejection region or not? Hmm? So it is minus 1.58. So it is minus 1.96. This is plus 1.96. So what will be? So this will be minus 1.98, 97, 96, 95. Agree? Here somewhere it will be minus 1.58. Obviously, right, guys, because it is minus 1.96 and you're from here, you're coming to this positive side. Here it will be 1.96. So obviously, you should increase the values. Fine. So here, somewhere over here, it will be minus 1.5. Obviously, greater than this minus 1.96. Okay, this point. So is this rejection region?
No.
No, right? This is no rejection region. Okay, only these are rejection region. Okay, this is rejection. Reject what? What we're rejecting here? Null hypothesis.
Null hypothesis.
Okay, so here also reject. Here accept. Agree? Accept null hypothesis. So since our value is falling in yesterday scenario, what was our test statistic? 3.28. Okay, and our value, critical value, starting from 1.65. Okay, 1.65 is over here, and our rejection region, anything greater than 1.65, this complete thing was our rejection region or critical region, rejection region. 3.28 means obviously it will be somewhere over here. Fine. So this complete thing is rejection region. So since our value test statistic is falling in the rejection region, fine. So obviously we have rejected the null hypothesis and accepted the alternate hypothesis. Clear? But now our test statistic is not falling in the rejection region, either this side or this side. Okay, it is falling inside this region. Okay, this accept region. So obviously here, can we reject null hypothesis? No. So this scenario, what we are going to do, accept null hypothesis. Okay, and reject alternate hypothesis. Okay, now what is they saying? Actually, what is null hypothesis saying? That mean equal to 50. Okay, mean equal to 50. And what is alternate hypothesis saying? Not equal to 50. So not equal to 50 is now disproved. That means yes, whatever the place where for company is saying that the average weight is 50, that is true, that we can accept it. Okay, because our test statistic from the sample whatever we are considered, so that is falling in the rejection, not falling in the rejection region. Getting is?
Yes, sir.
Okay, fine. So this is one more example, so how you can work on the two-tail test case. Okay, and yeah, so for example, let me just focus on this formula. So what happens if the number of samples increase, guys? If number of sample increases, then this value increases. If this value increases, this overall value, denominator value, decreases. If overall denominator value decreases, this overall z value increases. Okay, agree? If z value is increasing, okay, if z value is increasing, what happens?
It will be rejected.
No, if z value is increasing, okay, this overall value will increase. That means you will have lesser and lesser rejection region. Am I right? I'm just asking. See, I'm trying to understand what if n is what is n, guys? N is samples, right? Number of samples is 40. So if we take more number of samples, okay, so this n will increase. Okay, instead of taking 40, what is our n? 40. So if we take 100, this will increase. If this increases, the mu by rho by this overall value decreases. Okay, if this value decreases, this overall this value will increase. Okay, this overall this value will increase. So if that is increasing, what happens? Z value will increase. So Z is increasing means you will have lesser and lesser rejection region. That means the Z instead of 1.96, it will also increase. It will be over here. So you will have very small rejection region. So there will be more chances of accepting the null hypothesis. So if the samples, number of samples are increasing, okay, so the null hypothesis is getting favored. Okay, fine.
Sir, if Z increases negative value, no, sir. It indicates negative sign.
Yeah, I agree. So, but in this scenario, also, that's a good point, but it depends. So in this scenario, it is positive, right?
Yes, sir.
Okay. So yeah, so it depends on mean and the population. So if the sample mean is greater than the population mean, okay, and in that scenario, if the n is constantly increasing, okay, here it is 30. Now if you take 300, so this whole value will increase and this will decrease. Is this whole value will increase. Okay, that means this will obviously increase. Okay, but right, as you said, if it is negative value, okay, if it is a large negative value means, yeah, it will go this side, right, Sirisha? So even in the negative scenario, if it is minus 1.58, instead of minus 1.58, if you have minus 10.58, so instead of here, it will point somewhere over here. So that means rejection region is still decreasing.
Okay, area. Okay, understands.
Area.
Rejection area.
Rejection area. Okay,
Okay, sir.
fine. So okay, these are regarding the two concepts. Okay, are we good, guys, with these two concepts, two examples? Okay, fine. So now there is one interesting thing we need to study. Okay, see, guys. Where was this? Yeah, this one. Okay, so this one I would just like to put it over here. Okay, just give me a second. Yeah. Okay, so this is actually very interesting. See, guys. Now, yeah, in null hypothesis, yesterday I was discussing that you're having null, you're having alternate. Okay, so let's say you're the actually that means by how do I put it? So yeah, based upon an event, you have formulated null and alternate hypothesis. Okay, so let's say you have accepted the null hypothesis. Okay, accepted null hypothesis based on your test. Okay, but actually it was false. Okay, the null hypothesis was false, but we have accepted it. Okay, so whatever the null hypothesis was stating, that was false, but we have accepted it. That is wrong. Second scenario is whatever the null hypothesis was actually true. Okay, actually true, but we have rejected it. That is also false. Sorry, that is also wrong. Okay, it's an error, right? So even if you accept a false null hypothesis, that is also an error. Or if you reject a true null hypothesis, that is also an error. Agree? right? So that means, see here, over here, you are getting mean null is he's saying it as 50. Okay. Let's say you have proved everything, okay, and now you're accepting this null hypothesis. Okay, that's fine. It is perfect according to test. But suddenly, when you have visited the company, okay, you understood that whatever they're claiming is this is wrong. Whatever the claim they are doing is that is wrong. That means this is false. Actually, the null hypothesis is false. Okay, but based upon your test, based upon your test, you have accepted it. Okay, so that means what? You have accepted a false null hypothesis. Okay, you have accepted a false null hypothesis. Okay, in otherwise scenario, this is actually true, but based upon your scenario, based on your test. Okay, so in this test, suppose if you do some mathematical calculation mistake, okay, what happens if at all this value is coming as -2, for example? Okay, so you did some mistake, and this value you got it as 2. That means what? It will fall in the rejection region. Agree, guys? It will fall in the rejection region, and in that scenario, what you will do? You will reject the null hypothesis. Agree? So that means what? That means what? Actually, the null hypothesis was true, but you have rejected it. But later you have found, hey, oh no, there was some mathematical mistake or calculation mistake, but I have falsely rejected the true null hypothesis. Okay. So there are two types of error you can make. Okay. So what is your decision and what is the actual null hypothesis, true or not? Okay. So see, if the null hypothesis is true and you reject it, okay, that is one type of error. Okay. If you see, first of all, wait, let's see the what is the perfect scenario. If the null hypothesis is true, okay, and your decision was not to reject, okay, you're not rejecting the null hypothesis, that is correct decision. Agree, guys? Are you getting? Are you trying to understand the logic here? See, guys, if the null hypothesis is true, okay, actually the null hypothesis is true, okay, and you are decided not to reject it, that means you are accepting it. Okay, so you're not rejecting it. So obviously that's a correct decision, right? And if the null hypothesis is false, okay, and you have decided to reject the null hypothesis, okay, it is false, so obviously you should reject, and you have rejected. So that is also correct decision. Agree? Do you agree, Meghna?
If it is false,
No. See, first of all, if null hypothesis is true, should I accept it or reject it?
should I accept?
Okay. So if null hypothesis, if null hypothesis is true, okay, if null hypothesis, let's say null hypothesis is true, what I should do? Obviously, I should accept. Agree? If null hypothesis is false, what I should do?
Reject.
Reject. Simple. If we will always accept the truth and we'll reject the lies, false. Simple. Now, if null is saying whatever null is saying true, we accept, that is perfect. Whatever is saying this is false, if we reject, that is perfect. Okay. So here also there are different scenarios. Actually, the null hypothesis is true. Okay. What we should do? If we have, if it is true, should we reject or not reject?
Not reject.
Right. So if it is true and if we have not rejected, that means this scenario, that means this is a not reject, true. This is correct decision. Getting? Your decision is correct when you have not rejected a true null hypothesis. Okay. This is true and you have not rejected. Similarly, let's say your null hypothesis is false. In this scenario, what we should do? Reject or not reject?
So repeat question.
Hmm?
Can you repeat question again?
Yeah, see, I'm saying if the null hypothesis is false, Okay. In that scenario, what I should do? Should I reject or not reject?
Should reject.
Reject, right? So that's why if for a false null hypothesis, if I reject it, that is a correct decision. Okay, simple. If it is true, do not reject, correct. If it is false, if you're rejecting, that is correct. But the mistake will happen when you do the other way around. That means what? If it is true, okay, if it is true, but you are rejecting. Okay, it is true, but you are rejecting it. That is error. Agree?
Yes, sir.
Okay. And if it is false and you are not rejecting, okay, actually, if it is false, you should reject it. But if it is false and according to your test statistic and whatever you have calculated, you are not rejecting, that is also error. Agree?
Yes, sir.
Okay. So there are two types of errors. One is type 1 error, one is type 2 error. Type 1 error is also called as a false positive. Okay. So that means when you reject a true null hypothesis. Okay. So type 1 error is when you reject a true null hypothesis. Null hypothesis is true and you have rejected. That is type 1 error. But type 2 error is when you accept a false null hypothesis. This is false, but you are not rejecting. That means you are accepting. Okay. So when you accept a false null hypothesis, that is type 2 error. Clear?
Yes, sir.
Okay. So there are two types, type 1, type 2. Type 1 is when you reject a true null hypothesis, type 1. Type 2 is when you accept a false null hypothesis. Okay. So that is type 2 error. Okay. So yeah, so there are specific names for this type 1 and type 2 error. Okay. But I think we can cover that in the next class. Okay. So I would like to stop it over here because yeah, suppose that we have some other examples. Okay. Fine. Yeah, any doubts, Megan, over here? Did you understand the type 1, type 2 error?
Yes, sir. I understood.
Okay, fine. Okay, so let's continue in the next class. Thanks everyone.